Okay, so here we're going to talk about how to find the molar mass if we have a freezing point or a boiling point. So in this situation we have 50 grams of a solute that is molecular. It dissolves in 100 grams of water, and the resulting solution freezes at 15.5 degrees Celsius. That's negative, below zero. So if we want to find the molar mass, the first thing you're going to notice is that molar mass is not in this equation. But we can derive it, starting with this equation, if we know a couple of things. First of all, molality is equal to the moles of the solute over the kilograms of the solution. Now, what we can do is we can go ahead and substitute molality and arrive at a new equation. Delta T is equal to I Kf times moles of the solute over the kilograms of the solvent. Now this equation here still doesn't have molar mass in it, but we know that moles is equal to the grams divided by the molar mass. So we can do a second substitution, and that would give us delta T is equal to I Kf grams. This would be all over the kilograms of the solvent and the molar mass. So from this point, finding molar mass is just a rearrangement of this equation. So the molar mass is equal to I times Kf times the grams of the solute over the kilograms of the solvent and delta Tf. So in this case here, to find the molar mass, we can go ahead and start plugging in the data we know. The Van Hoff factor I was 1 because this was molecular. The freezing point constant is 1.86 degrees Celsius kilograms over moles. The grams of the solute was 50 grams as given earlier. Now the kilograms of solvent, there was 100 grams, which is 0.1 kilogram. And finally, the change in the freezing temperature was 15.5 degrees. So if we look through here and look at our cancellations, we've got kilograms canceling kilograms, degrees Celsius canceling degrees Celsius, and the only units left are going to be grams and 1 over moles. So our units are going to be grams per mole, so we set this up correctly. Now it's just a matter of calculating. And so after we run the numbers, let's go ahead and do that. So 1 times 1.86 times 50 all over 0.1 times 15.5. We're going to get 60 grams per mole. So this is how you find the molar mass if you're given a freezing point or a boiling point. Now remember, if it's a boiling point problem, your constant is going to be different, so you have to pay attention to that.